Hi, everybody. I'm Steph. I'm today's fake kit standing in. So welcome to the Beyond Seattle SRE Meetup. I'm an engineering manager at Google. I manage an SRE team. You might have seen me at past meetups. I've given a talk or two, but I'm one of the organizers. This is just a note. Go ahead and subscribe. We've got all sorts of YouTube videos up from past talks. If you're looking to spend an afternoon learning something, you can go and revisit some of our past speakers. Quick thank you to the organizing group, and we'd like to welcome Dan Wilson to the organizing group. So thank you. These are all of the folks that help make the Beyond Seattle SRE group happen every month. So thank you and welcome. The note to join our Slack channel helps build community, keep in touch if you want to share job postings, anything like that. There is a link where we'll be able to send you a request to join. And I think if somebody could drop that link in the chat for folks to make it a bit easier, that would be great. Thank you. All right, so first up today, we actually have Zach from BoxBoat. Zach talking about love your infrastructure like software. So I'm going to go ahead and turn it over to Zach and let him take it away.
Oh, we had some music take over the background. So, hey, everybody, I'm Zach. I work for a company called BoxBoat, and today I'm going to be talking about love your infrastructure like software. Do a quick check, make sure everybody can see my slide deck. Yeah? Don't all shout out at once. All right, looks like we're good. So I'm an SRE at BoxBoat. One of the things that I do is primarily consulting SRE. So I go around to multiple companies, different companies for relatively long engagements, and either help them establish an SRE practice, fill in gaps in SRE practice that they may be having, or train new SREs. And so I wanted to put together something that was pretty friendly to early career SREs or people that are SRE adjacent and are kind of getting dragged in, are kind of moving towards SRE, but maybe aren't neck deep in the SRE watershed. So love your infrastructure like software. Infrastructure is really important, right? Like if you're a developer, if you're a cloud engineer, you're thinking about the code you're writing, to do some type of function, you're thinking about features, and what you really should be doing is you should be thinking about your infrastructure as well. You either choose the right infrastructure or runtime right away, or you iterate over multiple environments until you find the right one. Just as important as finding the right environment to run your software is how you provision, deploy, and recover that software on your infrastructure. And so cloud is awesome. Cloud gives you error reporting, debugging, logs aggregation, alerting as managed services. So you don't have to create your own. You don't have to write your own alerting software. You can just consume it as a service. And that's the great thing about cloud. But cloud can also be really dangerous because managed services that you can turn on really easily, you can accidentally turn off really easily, right? And so if you have a managed database running, somebody can log in and do something that they don't mean to do and knock over a database, right? If you have serverless functions running, somebody can log in, and if you're doing click ops, you can knock those off, turn them off. So things that can be easily turned on can be easily turned off. I once had a director of engineering somehow manage to deploy kubeflow pipelines into our production GKE cluster. I still, to this day, haven't figured out how he managed to do it, right? But he was clicking around in a web GUI, and he managed to stick kubeflow into our production GKE cluster. So provisioning by hand and deploying resources by hand or using shell scripts, that's a really dangerous thing to do in my eyes because it introduces unnecessary toil into the way you operate your software and into how you recover and remediate when something happens. And so everybody knows if you're an SRE, nobody wants toil. But Using managed services is a good strategy. Controlling managed services with declarative and idempotent tools is an even better strategy. All right, because that helps you avoid that ClickOps toil. So you should love your code, right? You love your application code. You send it through peer reviews. You make sure that everything is checked into your VCS. You should do that for your infrastructure as well, right? If however much you love your application code, you should love your infrastructure code as well, right? Because peer-reviewed code is better than siloed code. That's a hands down. Peer-reviewed code is going to be better code. So IAC will save you from interruptions, heartburn, and headaches. So the big thing that you get from IAC is you get this protection against drift, right? And so if you're not familiar with drift, that's untracked configuration changes that get introduced into your system, right? If you somebody goes in and fiddles with a database, fiddles with some kind of configuration setting, if not everybody on the team is aware of that, that's drift. You're drifting farther away from your desired state. So another thing that you're going to run into is you're going to run into unplanned interruptions, right? And we're not talking about planned interruptions to your service. So, planned downtime events or upgrade windows. We're talking about when something that is unplanned, and not just when a service goes out or a system degrades. It's just anytime your system fails to meet a performance goal. And so if you've got SLOs around those performance goals, when you fail to meet those SLOs or you're trending in the wrong direction, you can think of that as an unplanned interruption. And so drift is directly proportional to unplanned interruptions in distributed systems, right? If you're doing Kubernetes, if you're running some type of distributed system, drift is going to be directly proportional to the amount of unplanned interruptions that you have. Now, those unplanned interruptions and that drift, right, that turns into fragility, right? Fragility is that something breaks easily breaks when you introduce change. And so you can take unplanned interruptions and divide those by your sprint cycle length, your development cycle length, however you classify your cycles, right? If you do this little, made up math that I created, you get fragility. And so fragility is directly proportional to toil. Toil is this concept it's hard to put a number on, right? It's hard to identify it. You know it when you see it. It's work that doesn't really bring value. It's engineering work that doesn't bring value to your product, but it's work that has to be done. If you think of it as fragility is directly proportional to toil, and you can calculate your fragility, you can put a score on your system. You can kind of you can correlate a score to your toil. And nobody wants toil. So a fragility coefficient allows us to measure that fragility. And that's directly proportional to the amounts of toil that you have in your system. And then once you know it's there and you have an idea of how to measure it, you can start to really engineer it out of your system. So, I'm talking about fragility. That's changes easily break a system. The opposite of fragility is systems that are resistant to change. And that's not what we want, right? And so as SREs, what we really want is anti-fragility. We want a system that's easy to change, but that also benefits from change, right? So we want high velocity, small changes where developers are able to work on features and introduce features as quickly as possible that bring value to the system that we're working on. And so what we really want is to bring that anti-fragility into our systems by avoiding fragility and toil. And so going back to the IAC part of this talk, we're talking about idempotent tools in IAC. They go hand in hand with fragility, because if you can just boil a tool like Terraform down to its most basic feature, it's a true love story of idempotency and anti-fragility. Because what it's doing is it's running a diff between your desired state and your known state, and it's showing what that change is. And it's going to give you, in most cases, it's going to give you a plan to remediate those changes. Right. And so that's a way to find that fragility in your system and immediately remediate it. And so here's my last little soapbox slide. That SRE is more than reliability. It's really about excellence. And this is one of the things that when I'm working with early career SREs, I try to beat this into their head, that it's SRE is really about excellence. It's about being an excellent team member, being really good at engineering, and most importantly, really good at delivering whatever it is that you're tasked with working on, right? So teams that ship and remediate effectively and efficiently, they build good reputations as being a reliable team. Teams that engineer for anti-fragility by finding the fragile pieces of their system and engineering that away, those teams become really, really great teams at engineering. And those engineers generally become really great engineers. So SRE engineering is just anti-fragility. It's building anti-fragility into systems, whether it's software, whether it's platform. It's finding the fragile and toil parts and engineering them away. Opening up for questions. I'm relatively active on Twitter. You can find me there. You can also find me on LinkedIn.
All right. Any questions or comments, or I guess tweets for Zach?
I mean, I have a question, but I don't want to come across as inexperienced or naive in the field. I'm pretty new to cloud quality assurance or SRE engineering. But first of all, thanks for the presentation. I appreciate it. It was pretty quick and informative. My question is on the anti-fragility. Like when I think of anything running containerized in the cloud, I think of like a non-solid state, like especially in respect to demand. Like, you might have N instances on a given day, but then during the peak season, you could have like 10 N instances. So how do you deploy and then recapture resources with this anti-fragility, right? Like, wouldn't a person have to manually do that? I mean, are there tools out there that predict the demand and scale accordingly?
Yeah, so you can, especially the cloud offerings for Kubernetes, they're going to give you the ability to scale up and down. The anti-fragility part is about looking at, like, if you have SLOs set up for your services, right? You can count over, say, a 10 working day development cycle. You can look and see how many times did we breach our SLOs, right? And so if you, over 10 days, if you had 10 service degradations, right, your coefficient of fragility is 1, right? And that's not what we want. Over a 10-day working cycle, if you only had 1 SLO breach, you have a 0.1 coefficient. And that's what we want, right? So okay. We can't measure anti-fragility. We can measure fragility.
Okay. So
so the inverse of, right, a shaky system where something's always going down, that's what we want. But we still want to be able to introduce changes, right? So blue and green, canary, doing canaries, we can still introduce those changes, but not necessarily have something break all the time. Does that make sense?
Yeah, I got it. For some reason, I was thinking of the fragility, like, reducing toil was sort of automating those processes. But when I'm hearing you speak now, it sounds like you're measuring fragility sort of as a metric in a way to assess how well you're actually performing from a quality SLO perspective.
Yeah, and so one of the ways that you get that fragility out of a system is by automating things, right? Like, we don't want a person clicking things on a keyboard or using their mouse to deploy something. We just want a machine to do it for us because we know the machine's going to do it the same way every single time, right? Even using Terraform, you can automate your Terraform using something like Atlantis, so that instead of a person running Terraform and reading the output in their terminal, that gets pasted into a comment in your GitHub or GitLab, right? So that having a machine run things, that takes the fragility out, because what we want is that anti-fragility. That's a great question. Great set of questions.
All right. I think we have everyone back now. Is there a way to confirm that? I think that's the number we had last time. All right. So I'd like to introduce Letania. She'll be doing our next talk for how to achieve lower risk progressive deployments using error data. Letania is coming to us from Rollbar. So Letania, go ahead and take it away.
So, hi everyone. I'm Letania, and as Steph said, I'm talking to you today about how to achieve lower risk on progressive deployment using error data. Lower risk would be a pretty cool thing to talk about too, but let's go with
you can use that for next time. That's my point.
Next talk. Okay.
Somehow more complicated than what you're going to talk about today, I think.
True to that. Yeah. But anyways, so before I start, a little bit about me. I was born and raised in Brazil, and I first came to the United States to go to University of Illinois, where I got my PhD in linguistics. That was kind of like my gateway into coding, because I had to analyze a lot of data for my research work. And so after many happy years in academia, I made a smooth transition into software engineering. In my free time, I like to do yoga and to cook. And I've been at Rollbar for the last 2 years, where I'm a software engineer. And enough about me, and let's go back to progressive deployment. So progressive deployment has increased in popularity, and but there might be some reasons holding you back from using it. Like, maybe you think that if an error doesn't break your deployment pipeline, maybe you are not going to be aware of the error until it reaches customers. Or perhaps you think that progressive deployment requires constant attention. Like once you start the deployment, you're like tracking metrics and waiting for the pipeline to complete. You think you need to be there. Or maybe you think there's insufficient error signal, because it's not always like super easy to find exactly where your error is coming from, just looking at 500 status errors code. So that's where the toolkit that I'm going to be talking to you today comes into. The Rollbar toolkit for Kubernetes will give you total visibility and automated workflow. And so that can be done either like based on new or reactivated errors, and it's going to inform you in real time. And it's also going to help you to configure the automated actions, like rolling back your deployment workflow if needed. So basically, as soon as you have error data, like you are immediately notified, and then which allows you to take immediate action. But meanwhile, your deployment has already been halted by the Flagger operator that we use in conjunction with this tool. And so basically the idea is, instead of letting your development rely only in performance related data, such as latency or HTTP status codes during the progressive deliveries, like we're proposing like that you deliver an important signal to your automated decision making, which is like code quality. And then using the application level bug data, which, as I said, it could be, reactivated errors or new errors, but using this data to signal to automatically how to sustain your canary release. So imagine the following scenario, right? Like no more anxiety every time you deploy. You don't need to be watching your deployment closely. I'm proposing that we move from like monitoring metrics and we set an alert. And so let's start like looking what your cluster would look like. What would it be in your Kubernetes cluster? So, so here you have the toolkit, and the toolkit is gonna call the Rollbar API once you have an error on your Canary deployment. The toolkit, which is like constantly calling the API to export metrics on Prometheus, is gonna get this data. Oh, there's a new problem here. And then Prometheus now is informed of those metrics, and Flagger, which is a progressive delivery operator for Kubernetes, Flagger is going to use that information, right? And if you see there's an error, Flagger act as a human and halt your deployment. And so it's gonna halt your Kubernetes deployment, and it's gonna kind of like give you the opportunity to go there and fix it. But basically the toolkit's gonna keep on checking for you to see if everything is in place. You don't need to be watching it yourself. And you're just gonna be informed in case you have a problem. So what does this bring into you? It is ability to just set up your cluster and deploy with the confidence that you can automatically stop your Canary rollout the very moment that a serious problem appears, right? A bug appears. So here's like, let's take a look at your workflow. So you release a version, and then Flagger deploys your Canary at 5%, for example. So if there is a new error, but let's suppose that this error is not critical, then you could, for example, just mark it as a warning, and then you continue your workflow normally. If this error comes around again, it's not gonna intrude on your workflow any longer. Let's suppose, on the other hand, that it is an important error. And so once you get there, it is gonna halt your deployment. And once you get there in the triage, you're gonna try to fix the error. But supposing that your fix didn't go that well and the error comes around again, then Flagger is gonna halt your deployment one more time. And so basically, it's like a possible dream. You can automate your deployment, push it out, and move on with your day, knowing that if there is a problem, it won't pass by you. You don't need to be watching the metrics, and you don't need to be waiting for the pipeline to complete in order to do that. Let's take a look at what is in the toolkit that would make that happen. So the toolkit has two main parts. One is the project operator. So the project operator has a project CRD that defines the Rollbar project inside of the Kubernetes cluster. And it also has a project controller, which commands the API. And then the other part is the Prometheus exporter. The exporter calls the API to expose the Rollbar data to Prometheus. And then it also has the controller, which manages the configuration for the data, which data to export. And this configuration enables the automated progressive delivery to work with Flagger like exactly the way the Flagger is built. And the goal of the project operator is to make it really easy to configure Rollbar inside of your Kubernetes cluster. So let's take a look at what you would need here. So basically, the first thing that you see is that we're using declaratives resources like in YAML, like following GitOps principles. And the things that you would need to provide, you would just need to provide a name for your project. If your local project is different than the project name that you have for Rollbar, or sorry, in Rollbar. So your data is organized in environments in Rollbar, And the declarative makes the tokens available in your cluster. So there is no need to add a token. The toolkit creates one for you. You basically just need to provide the token scope. And then that's it. Once you have put those steps in, your project resource is now on the cluster. All you need to do after that is to connect the deployment to the project inside of the cluster. And you do that by providing some annotations. So you need to provide the project name, and also you provide a version. The version can be a Git SHA. This Git SHA is what allows Rollbar to show you exactly where the error in your code has happened. And so this isn't the case that you just have like one container inside of the pod. You go with short annotations. Let's suppose that you have more than one container. Then what you would do in that case, you would provide longer annotations. So you would be able to differentiate between the two containers. So annotation keys are used to inject the values into the container to configure the SDK in the container. And now all that you need to do is to say which version, token, and environment the container is using. And with that, you're done. The deployment is connected to the project inside of the cluster. The Prometheus exporter goal is to enable tools like Flagger to use data, Rollbar data associated with those decisions. So let me show you how to configure the project operator. All that you're gonna need in your canary is a target deployment by name. You probably wanna use a larger interval to safely check for errors.
Mm.
And we need a customer metric template for analysis. You also gonna need to set up a threshold for the errors. Here, for example, I used like 0 because I'm working with the hypothesis that you don't wanna let any errors pass by you, but that you customize as you will. And the toolkit uses webhook, which let Prometheus exporters know when there is a new deployment, if the deployment is being promoted or if it's being rolled back. So it will export the desired metrics. And on Flagger, what you're gonna need is to add the same name that you used in the canary. And you're also gonna need some annotations to generate the proper metric queries. And here, you're gonna use project, environment, and version labels. And there are a few things to be aware. The annotation keys are not proper goal identifiers. So you must use dictionary assessors, or you can use a range, like in the Helm template. And also the deployment data, all the deployment data is included. So you can use labels as well. What else I'm gonna tell you here? Let's take a look at the Prometheus metrics that are being generated. So here we are adding up the new and the reactivated errors. And you have the labels to refine your query, version, project, and environment. And then the metric template in Flagger allows to create metrics on Prometheus that Flagger will use. And then that's pretty much it. Your team can spend less time monitoring deployment and more time coding. So the toolkit is gonna lower the deployment risk and resolve critical errors faster by automating this stuff. And so benefits for your developers are lower risk on the deployment, reduced manual effort, which, you know, as Zach showed us, increases the fragility. Manual efforts increases the fragility of your code. And it also, the toolkit would also help you with faster resolution of critical errors. for the business, you're gonna have like fewer escaped bugs, and then by consequence, improved customer experience with better quality on the applications in production. And that's pretty much it. Let me know if I can answer any questions.
Any questions for Letania?
I have a question. If I want to try it out, where can I get started? Maybe you said this already.
No, actually, you can go to rollbar.com. Yeah, let us know that you're interested on the toolkit. And then you're gonna be able to sign up for the beta page, because this is still in beta.
Well, thanks.
All right, thanks. Good question. Anybody else?
Are the logos on the front page all companies that are using the product?
Logos on the front page. I don't recall putting logos on the front page, but
So on
yeah.
rollbar.com.
He's probably just talking about the
Oh
website.
yes, okay. Well, I
Yeah,
thought you're
sorry.
talking about like yes, yeah. With the rollbar.com page, yes, customers of Rollbar. Yeah.
That right there is a sign of somebody that's deep into the engineering, because they never go to the homepage.
Oh, it's very far away from the CLI, isn't it?
All right. Any last questions for Letania? Okay. Then it sounds like
sorry, I had a question. Just that if you have a smaller organization, right? And so I'm not, we don't have the volume of users, say Google has. When it comes to Canary releases and using errors to give you this feedback, what kind of volume do you need to get useful feedback loop with errors?
I don't know if necessarily like, there's a lot of different things that you can think about, right? Like one of the things that it is happening there is that like we're gonna halt your deployment right at the moment that an error that you consider critical appears. So you don't really need a lot of volume for that. Like if something is critical and it's gonna be, taking your deployment down or causing big problems to your clients, like it is critical to your business despite of the volume. So I would think that volume is not necessarily like the biggest issue there, if that makes sense. As well, like you can run automated tests against it to sort out the errors, and like we are gonna catch all sorts of errors, and we sort like we catch like the errors beyond the HTTP 500 errors, and then because when you look at the 500 error code, like where is this coming from? Like when you get to that to Rollbar, you're gonna see exactly like the line of code and the file where the error is at, right? And that's what speeds up your process, because you don't have to guess.
Thanks.
Sure.
okay. That was also a good question. Are there more good questions out there?
We accept bad questions too.
Yeah, absolutely.
yeah, is that this is something I wish I would have had 2 years ago, instead of sitting having to just watch for the error reporter in GCP and have that thing send me notifications to my phone all night when something started going bad. I would love to have had that automated away. So yeah, thank you for building this. I wish I would have had it 2 years ago.
I was wondering about who's on this call. Who's doing Canary releases? I can't see any.
Oh,
But
I'm raising my hand like you can see me. But
I can see you, Steph. I can see you, Zach. Yeah. And so yeah, I would just say in terms of our SRE maturity, we're not really there yet. I mean, we do it kind of for features per se when we do a small sample of like when we're releasing a new feature, but that's more of a business metric and less of a reliability that we're looking for. So this is definitely something I'm interested in moving forward with.
Yeah, for me personally, our team, we have kind of internal ones, but we also have some set up with customers where customers can test their workloads against upcoming release versions, to kind of help identify problems in that way as well. So there's different ways of doing Canary or different layers. Anyway, more questions.
Yeah. And if if not Canary, like it would also work with A/B testing, with like deployments, which Flagger supports.
okay. Any other questions? That's it. Last call for questions. We keep getting some good stuff here.
Yeah, really good questions. Thank you all. Like making me think about this stuff.
Okay. Well, thank you to both Zach and Letania for presenting today. We would love to have you keep coming back and be part of the audience and the breakout groups. So if you're looking for when we're going to be next, we are looking at February 17th. Again, that's from 3 to as late as 4:45 PDT, since we are based out of Seattle. Sorry, next slide. There we go. We also have an SRE coffee hour that you're always welcome to enjoy. So the sip, relax, engage. Coffee mugs are also part of the meetup. Kit, are we still doing mugs? Or are we out of mugs?
We got mugs.
We got mugs. So we do have a link on the meetup page for, okay, I want the mug. If you bring a friend to the meetup, we have a form you can hit based on honor system. We will send you a sip, relax, enjoy mug. If you are big fans of like the reliability joke, you can come enjoy some tea and sip and talk with SREs. And as Kit mentions, we use the honor system. So, but it will be your new favorite mug. So the next one of those is happening Friday, January 29th from 9 to 10 a.m. So if you want to kick off your Friday with us, we'd love to have you join. You can find the link below, but if you're following the group on Meetup, you should be able to just RSVP to the next event. All right. And again, thank you. So you can go ahead and fill out this survey. The planning committee does take a look at each and every one of these to try to continue to make the meetup better, especially while we're meeting remotely. And so we were so glad that you could all join us today. And hopefully next time you can join us again and bring a friend.